What is up, everybody? Today, we're going to be looking at an SAT review. More specifically, we're going to be looking at what geometry questions you're going to be seeing on that SAT exam. In that process, I'm going to be analyzing and showing you all solving strategies and sort of the essence of those geometry problems that pop up on this exam so often. As always, if you're new to this channel and you like this video, give me a thumbs up below and slap that subscribe button. But for now, let's jump into the review. Okay, before we get started, I want to let you all know that there's two sections to this SAT exam. One section, the first section, will be without a calculator, and the second section will be with a calculator. Without a calculator, you will see something where a problem like this, where there is no multiple choice answers, whereas the calculator section very often will have your multiple choice answers. So it's not to discourage you, because honestly, oftentimes where you do have sections without a calculator, the problems are actually easier. For example, I don't need to read this problem to know exactly what they want. Notice, I'm just going to look and highlight in yellow. This is the value of x, right? It's this measurement. What do we want to find here? We want to find AE.
I know that just from looking at this figure.
But I'll entertain the test takers just because that's what we do. And I'll read. It says,
a summer camp counselor wants to find length x in feet across this lake represented by the sketch above.
So this thing is this lake.
We have these 4 bits on the sketch, and they correspond to these values.
So right away, I'm just gonna kind of put these ahead. So as you can see, I just wrote out what my values were here, and then went up and kind of wrote what I have. So notice, like, I don't have this value. I'm still trying to find this one, but I have the other 2 values. I don't have this value here. I don't have BC, but I have the other 2 segment measures. And let's see what else we're told. That these segments intersect at point B, okay, and that AEB, this hash mark here, is telling us that these 2 angles are congruent. They have the same measure. So I'm just going to highlight these as well. I don't really like this color.
More of a softer pink. How about that?
What we know, we have 2 lines intersect. 2 segments intersect at point B. On either side of the intersecting segments or lines, we have a congruent angle. This is a vertical angle. And so that means here, I'll make this one 2. So if I'm looking here, I have angle 1 was given to us. We know just from our given information that these 2 angles are the same. We have angle B is congruent to angle B, and of course I would use more points here, but I'm just trying to get this point across. So we have 2 measures that are the same, and then we have this other angle, angle C, and angle A. And if 2 measures of the triangle are the same, then the third one is also the same. This is the supplement theorem. It's pretty easy to deduce, but just something to remember. But anyway, this is clearly a similar triangle, right? We have the triangle on the left, this one in yellow here, and then I'll make this in purple, is similar to the triangle on the right. And so we can just set up a similarity. What do we have here? Well, we're kind of pigeonholed into what we can do, because we have our 2 corresponding sides here in purple, AE and CD. We don't know what it is. So what I'm going to do is I'm going to set up a ratio of corresponding sides, which is the definition of a scale factor, and I'm going to make that into a proportion of the remaining sides. So just be close. Just look carefully. BD corresponds to what other side? Well, it's between angles 1 and 2. So over here, I'm just going to look at what side is between angles 1 and 2. Oh, 1 and 2. Angles 1 and 2 is EB, and that is 1400. So I will put, this is going to be 700 over 1400. And now simply cross multiply and divide. Find the cross product. This is 700x is equal to 800 times, I'm just going to write 800 times 1400. And this is algebra at this point. What are we going to do? Of course, divide both sides by 700. So we find these two things cancel out, obviously. And we're left with x is equal to, and this is all calculator work, 800 times 1400 divided by 700. We get 1600. So what this problem boils down to is, can you recognize similar triangles? Do you know that when you have a couple angle congruencies, that the third one is implied? Do you know the law of supplements? It shouldn't be that hard to recognize, and once you see this figure, it's hard to forget. Okay, now some of
You're going to see this start flipping out.
and I say that because this looks really weird. But what I'm going to do is I'm going to draw a triangle and just show you that
This is not weird.
this boils down to, do you know SOHCAHTOA? Do you know that the sine of an angle is equal to opposite over the hypotenuse? And do you know that this cosine of an angle is equal to the adjacent over the hypotenuse? And that's all. So I know, okay, I know. SOHCAHTOA. And this is sine, opposite, hypotenuse, right? So this is sine of the angle x. Let's just put the angle x down here, right? And I know that that means that the opposite side, opposite, will be the one across. So opposite is 4. And the hypotenuse is the side across from the right angle. So the hypotenuse here is 5 units. Now, let me just remind us. I'm going to deal with whatever this is. I'm going to deal with it actually pretty simply. So what I'm going to do here is this is the sum of a triangle, right? So the sum of the triangle is equal to 180, total interior sum. And this is the angle x down here. Let's just make this x degrees. So we know that it's going to be some measurement x degrees plus some measurement 90 degrees, right? Because we have our right angle. Plus, and I'm just going to name this angle over here just for convenience, y. Right? Let's just name this y. And what I'm going to do here is I'm going to use algebra to solve for the other angle. I'm going to do this pretty quickly. 180 minus 90 is 90. X minus 0 is minus x. And that is equal to the angle y. And notice, doesn't that look familiar? Of course, the leftover angle will be 90, this right angle, minus the angle we're given. I mean, of course. So I'm just going to change this to the cosine of y. Because incognito, these two things were the same, right? And I just showed you that. And so the cosine of y, cosine is adjacent over hypotenuse. So here is y. The adjacent is the side beside it. That's a mouthful. So it's 4. And the hypotenuse, which was the angle, the side across from the right angle, 4 over 5.
And really, the cosine of this junk is 4/5.
So what's going on here? This is just asking you, can you deal with something that's disgusting and sort of process it? How do we deal with this? Well, if we know we're using trig functions, it has to be a right triangle. Do you know where to start? Do you know what this means at first? And so what I did was I'm just setting this up. Sine of x is 4/5, so opposite hypotenuse. That leaves me with some other angle. And notice that that other angle is actually just the other angle. If this was x or y, you could use alpha, beta, gamma, theta. It doesn't matter. You could call it 100 different things. You could call this one Ralph and this one Stuart. It's just how it goes. And you can see that clearly the other angle is going to be 90 degrees minus the first angle. That's what that angle is. Literally, it says the other angle is 90 degrees minus the other angle. And of course, because this is a triangle, and triangles have an interior sum, so 3 angles, the interior sum has to be 180. And all I did was do a little bit of algebra here. Easy peasy, squeezy, lemon. So in dealing with this problem, first thing I'm going to do here is I'm going to make one of these transversals go away. So I'm going to actually take away this transversal. So just imagine this one being covered up and kind of out of the way. And what I'm going to remind us is these properties of transversals. There's only two that you need to really know, and it is alternating interior angles. And I say that because notice we have a pair of vertical angles right here. So these two angles are congruent. And then alternating interior, so this angle down here is also angle 1. And then so is this one. So all 4 of these angles are the same measure. Now what I'm going to do is I'm going to show you just a different way of thinking about this. So I'm just going to take this, turn it on its side, and now I'm going to get rid of this transversal. And I'm going to do the same thing. And now we can see how these angles are related, and we can focus in on this part right here. And then this last piece is the other bit. It's a linear pair. So we know that the measure of angle 1 plus the measure of angle 2 is equal to 180. To find the value of the measure of angle 2, which is 45 degrees.
Super easy.
I mean, this is basically a layup. This is like your fast break on a soccer field, and the goalie is literally
Garfield sleeping, eating lasagna.
And here you are. I mean, these are free points. This is on the SAT. This is literally an SAT problem. When we have this, we just have to turn back and look at our formula. So the volume of a cylinder, is equal to pi r squared times the height. So all this is the area of the base times the height, which is the volume of anything. And so if this figure did look different, what I like to try and have people do is imagine this is your base, right? And it's being lifted up 8 yards, and it's going to the other base. So the base is just being lifted up 8 yards. Let's see what we have here. It says, a dairy farmer uses a storage silo that is in the shape of a right cylinder above. If the volume of the silo is 72 pi cubic yards, what is the diameter? What is the diameter in yards? What's the diameter? So the diameter is the whole way across the circle here. So what is that value? So I'm just going to go ahead and just kind of remind us that we're looking for this whole bit here. We're looking for that. And don't forget that all the diameter is the radius times 2. And notice we have the radius. So we have V. What was the volume? We have V. We're told that the volume of the silo is 72 pi. So we have 72 pi. What is the diameter? Well, let's find out. We know that we're going to have this bit over here. We have the area of the base, which is pi r squared, and it's going to be multiplied by the height, which is over here we see as 8 yards. So this is going to be multiplied by 8. And let's just do some ouch. Let's just go to town. Let's just make it happen. Okay, so what are we going to do here? Before I do this, we're going to be solving for r. We need to find the radius and then multiply it by 2 to get the diameter. So
I'm looking and cooking for r.
So I'm going to put a little box on it. I'm going to put a little bow on it. How about that?
Let's put a little bow on it.
We're looking for r, okay? We're cooking for r. She coming over later.
We're trying to press r.
All right, so here we go. What do we do with something we're looking for in algebra? We're going to divide everything else out. We're going to use inverse operations. And what we got going on here is just a bunch of multiplication and a little bit of squared. So first thing I'm going to do is divide by the number pi and divide by the number 8, because 8 divided by 8 is 1, pi divided by pi is 1, and that means that on the right I'm left with just r squared. 72 divided by 8 is 9, pi divided by pi is 1, so we're left with r squared is equal to 9. This says some number times itself is equal to 9. So even if you don't know how to get rid of the squared, you should probably know that some number times itself is equal to 9. Is it 1? Is it 2? Is it 3? But let's just do it the right way. Find that r is 3. But remember, we wanted to find the diameter, so we found r. It's 3. And how do we get from r to d? Well, we just multiply it by 2. So the diameter in yards is 6 yards. This is entry-level algebra, which all they're doing here is asking you, can you do algebra? Can you isolate a variable? And I know that sometimes when we get down to this part and we're like, uh-oh, what do we do to squares? Oh no, just ask yourself, r squared is 9. Some number, r, times itself squared is 9. What number squared is 9? Not 1, not 2, it's 3. Bada boom, bada bang. Figure not drawn to scale. However, what I will like to do is just point out that this is not a vertical angle. Just like to point out that this is not a case where we have a vertical angle or even a transversal region, because angle Y and angle Z are not made by two intersecting lines. As you can see here, a line wouldn't behave the way that we see in the figure. So just don't be so quick to say that Y is equal to Z. This is actually not a case of vertical angles, which are so important to be able to visually recognize. Okay, but let's see what we do have here. So we're told that if 180 degrees minus Z is equal to 2Y and Y is equal to 75, what is X? So it looks to me that good old-fashioned algebra is at it again. So I'm going to go from Y to Z, then from Z to X. So that's going to be sort of the flow of this problem. So let's solve for Z. So we're told right away that 180 minus Z is equal to 2Y. Again, I want to solve for this, so I'm going to get it all alone. You might be asking yourself, Hizzo, I got nowhere. Like literally you got me stuck somewhere. But remember that Y is 75. So minus Z is equal to 2 times 75 minus 180. So up here, I'm just going to write Z is equal to 30 degrees. And I'm just going to get rid of this stuff. And I'm going to work on the figure. So I know that isosceles triangles have 2 congruent sides and 2 congruent base angles. So if I'm just going to call this one angle A and angle B. So I know that angle Z plus angle A plus angle B is equal to 180 degrees, right? We know that Z is 30, but these two things are the same. Angle A is angle B, right? So up here, angle A is angle B. These degrees are, remember that the equal sign is the word is. A is B. So this is A plus A is 180. And we have angle A and angle B are equal to 75. And now, all we have to do, I'm just going to put 75 in here, because all we have to do now is recognize that this is a linear pair. It's our favorite fruit. And so we know that this is true, that 75 degrees plus the measure of angle X is equal to 80 degrees. 105 degrees. Really nothing to this problem. Just solving for a variable and making your way over. It's just a long algebra problem. No big deal, really, MBD. Okay, this is a right triangle, so I got my right angle down here. We're told that measure of angle B is 90. BC, so I'm going to call this one C. This is 16. AC, so let's call this one A. is 20. Triangle DEF is similar. So I have another triangle. Let's make this one N. So here's my other similar triangle. And notice ABC, where am I at? DEF. So A corresponds to D, B corresponds to E, and C corresponds to F. So your triangle, your similar triangles should look like this. And each side of the triangle is 1/3 the length of the corresponding side. Oh, so it's almost like there's a scale factor. But what is the sine value of f? So we have to find out what measurements are going to be the hypotenuse and the opposite. So first thing we're going to have to do is find AB, because this is our unknown side. So let's just do the Pythagorean theorem. And I'm just going to leave that B, and that will be our side AB. So this is just saying that some number times itself is equal to 144. Come on, you know what that is. But I'll just do one more step. Square root both sides to get rid of the square. Square root of 144 is 12. And so we find our missing value here to be 12. These triangles are similar. So that means that the sine of the one angle is going to be the sine of the angle. So that means that the sine of F is going to be equal to the sine of C, because these values are the same, because F is C. Duh, angle, 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 similarity. So really, all I have to do is find the sine of C, and that'll be the sine of F. Man, they tried to trick me. That's okay. I almost got into it. So let's look. We have the sine of C is going to be opposite, 12, over hypotenuse, 20. And that's really it. So the sine of F is going to be the same, 12 over 20. This value is 3/5, or 0.6. Oh, just remember that's one of our fundamental principles, is that similar triangles are angle, 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 similarity. If two triangles are similar, then all three angles are the same. So angle F is angle C, and thus we can just make this conclusion, not assumption, conclusion. Oh. What do we want to do here? Okay, so let's see. If these are sine and cosine values, that means that there has to be a right angle somewhere. Yeah, I'm gonna just assume that there is a right angle here somewhere, right? That some angle here is a right angle, and that means that I'm just gonna kind of redraw this triangle with, because they're both acute. So that means that A will be in this corner, and B will be in this corner, and so I know that A plus B plus 90 is going to be equal to 180, right? Because these are all three bits of a triangle. So let's subtract 90 from both sides and see what we have. We have that A plus B is equal to 90. And now we can do a solve. And really, like, this is what you got to remember. You got to remember that, yeah, this stuff is scary. And you can really even use some advanced trig. You can use some pre-calc trig on here. You might be able to be like, oh, what's the law of sines? Let me see the law of cosines. And I'm sure there's a lot of different ways you can do that. But,
and that's a big but.
So I just kind of drew the triangles, stuffed them in there together, and see what we can do, and really just did some common sense stuff. That if this is true, then we have these three angles, bada bing, bada boom. And you've seen me do this before. Like, this is legit an idea to happen. When you have sines and cosines, if they're on the same triangle, then this property is true. There's just very, very straightforward and obvious properties that are true. And in this case, we're done with this problem. This is A. That's B. Oh, and it's equal to 90. So let's just write that out.
That's it, man. All right, 10K is equal to negative 22 minus 30, minus 35 plus 90. That is 125.
We find K is equal to 12.5. C. It's really asking you what's in your tool belt. Do you have this in your tool belt? Can you take this idea of here's a right triangle, here's another right triangle. These two angles are not the same, right? Although their values are the same, but their angles are different. This is angle A, that's angle B. So let's put them in the same, angle A, angle B. Ta-da. All right, I have a feeling I'm going to be doing a lot of the writing. Let's see what we got. We have a grain silo.
Man, these silos are really out here.
Is built from 2 right circular cones and a right cylinder with internal measurements represented by the figure above. Let's see. So we got to just find the volume of this. All right, no big deal. It looks like, are these 2 figures the exact same? Yes. These 2 figures are the exact same. And how many do I have? 2. So what am I going to do? I'm going to find the volume of the one and multiply it by 2. So this is the volume of a cone. And again, this is given to us. This is given to us in the beginning. So volume of the cone is going to be equal to 1/3 pi r height. So area of the base times the height divided by 3. Just because I want a nice decimal value, so I'm going to have pi. Pi is junk, right? And so how I treat the junk is I throw it in the trunk in. So I'm going to put the junk in the trunk. So 5 squared times 5 is 125 times pi divided by 3. So there's 2 of these. 125 times 2 is 250. So double cone will be 250 pi divided by 3. So this is 2 volumes of the cone. Let's do a little draw there. Okay, so what do we got to find last will be the volume of the cylinder, which is, again, volume of the base, pi r squared, times the height.
And the height here, man, this is easy. This is a cake problem.
Pi times 25 times the height, 10. And so this is, again, hey, 250 pi. So we have 250 pi's plus 250 pi's divided by 3. I'm just going to put that value in my calculator. Depending on what type of calculator you have, you want to put it in just like this. You want to put it in just like this. The reason is because this is a number here. And if you put 250 pi plus 250 pi divided by 3, it's going to do this computation and then this computation. But what you want is to have this computation be all together and thus have to wrap that in parens. That our answer is 1047.19 or 0.2. And so our answer here is D. And really, there was nothing to this problem. This is another layup. You're
Wide open goal.
You're doing a dance recital, and the person in front of you literally fell off the stage, and they're okay, they're not hurt, but they're
Just that bad at dancing.
that they twist their big toe. Really, all you got to do is go up there and stay on the stage and remember your steps, and you win. So the prize goes to the victor.
This is a good one.
Now don't freak out. But let's just see what we have. We have the circle above with center O as a circumference of 36. So that means the whole way around this circle is 36 units. What is the length of the arc AC? So you have to think to yourself, what does this arc measure? And you might be sweating right now because I don't think the arc formula is on this exam.
And you're really like, oh no, oh no.
But here's the thing. You don't need to remember anything because, as you can see, this circle is cut into how many equal parts? Well, if this is a right angle, then that means this is a right angle. That means that this is a right angle and this is a right angle. So all of these parts are the same. All of these pieces here will all be the same. All of these pieces will be the same. And the total is 36. How many pieces are there? How many parts are there? There's 4. What's the total? 36. So our total is 36, and we want to find 1/4 of it. How do we take 1/4 of 36? Well, we can multiply 36 by 1/4, or of course divide 36 by 4. 36 divided by 4, 9er.
That's all. Believe it, that's all, folks.
That's all. All right, we're out here with another jackpot problem. Circular cylinder. So I got this big guy over here. Is 22 cubic centimeters. So we know that volume of a cylinder is going to be the area of the base which is pi r squared, times the height. So this number, the volume, is going to be 22. So I'm just taking that and just dumping that in there. So we want to find what is the volume of a right cylinder, so the same cylinder, that is twice the radius and half the height.
I see it. I'm getting rid of this.
We want to find volume. We're told that. What is the volume of a right cylinder with twice the radius? So this is 2 times the radius, that number squared, and half the height. So this is going to be times, let's do this in green, half the height. Now, big question is here, do you know properties of exponents? Can you multiply this out? So we're going to have pi is equal to, I'm actually going to put this as 22. Yeah, I'm going to put 22 here because that was our original value. And now what I'm doing is seeing what I need to multiply that other side of the equation by. So what I'm going to do here is I'm going to leave this blank. I'm going to leave this blank because we went from step number 1 to step number 2, and what I'm going to do is examine how the values on the right side of the equation changed, and then multiply the left side by that value, h. And this looks disgusting, but I promise it's going to look a lot better. What I'm going to do is I'm going to dump this pi in the back. I'm going to put the values in the front, 2 times 1/2, and then r times r is just r squared. So notice right here we have pi r squared, and then here is our h. So I'm just putting all the gross stuff in the back.
I'm putting the junk in the trunk.
And I'm looking at what's going on here. So we have 2 times 1/2. What's half of 2? 1. What's 1 times anything? Itself. So over here, this is 2, and what do I have left? I have this pi, I have the r squared, and the h. So my question is, how did this result change from the initial step? From our initial volume of the figure, what changed? The 2, right? So in order for this equality to hold, so the volume initially, let me just clear this up. So the volume of the initial figure was 22 units, right? And now, what did we do? We multiplied the right side by the number 2. So if we multiply the one side, we have to multiply the other side. So that means we're multiplying 22 by 2. Have to be multiplied by 2. In order for the equality to be true, whatever you multiply one side of the equation by, you have to multiply the other side of that equation as well. Can you work with something that's disgusting, right? Can you take the trash out?
Do you know where the junk go?
And my recommendation is I put the junk right into the trunk because this stuff is gross. It's not going to change. The stuff that I'm working with, these numbers here, that's the niceness. And what do I want to do with that? I want to have it up front. You know what I mean? I want to have it in the car with me at least. I can't be having the niceness in the trunk. I got to be showing it off. So now all I did then was ask myself, if I multiply the right side, I have to multiply the left side. What did I multiply the right side of this equation by? The difference between these two equations was the number 2. And this is multiplication. And so that means I need to multiply the left side by 2. And thus our answer here is C. Easy, squeezy, lemons, here we go. This is a triangle. Man, this is seriously triangle. All right, so what do we got here? We got a linear pair. It's our favorite fruit. So we're going to take 180 minus 106, right? Because we know that two things have to add together to this value. So it's just simple subtraction. Yep, so this is 74. So we get 74 degrees in here. And then we need to find out the measure of, let's just call this one y. And we know that 74 plus 23 plus the measure of angle y is going to be equal to 180 degrees because this is a triangle. So this is 97 is equal, plus y is equal to 180, and then subtract both sides by 97. So this is 83, and this is a linear pair. So the value of the measure of x is 97 degrees. Literally, linear pair, interior angle sum theorem, linear pair, bada bing, done. Like, this is a gift. This is Christmas morning. You know, you're waking up, you're ripping open your presents.
Oh, SAT, oh, SAT Christmas. Oh my gosh, I can't believe it. You gave me the easiest problem in the whole world.
Thank you, SAT Santa. Special right triangles. Oh man.
I know you wanted to see this.
Here's the thing though. Here's the thing. This is not the easy special right triangle either. This is the fun one. But I'm gonna pump the brakes here because they've given you literally another gift. Another gift. Here's the thing. What I'm gonna do here is I'm just gonna mark up this figure. I literally did not even read what they want to know because I don't care, because I know, like, it's literally at the tip of my fingers. This is the easiest triangle to work with, and a lot of you are getting all verklempt, all little
Tussled. Oh no, special right triangles. These were hard.
Watch this. So over here, we have 90 plus 30 plus, let's call this one, do I have an x here? Let's call this one angle x plus the angle x is equal to 180. Oh, 90 plus 30, 120. 180 minus 120, that value is 60 degrees.
Convenient.
Let's look at this side. We have 90 plus 60 plus, let's call this one angle y, is equal to 180. 90 plus 60, 150. 180 minus 150, this is 30. These two triangles are the same. Triangle's the same, but this is a equiangular triangle because 30 plus 30 is 60. So we have 60 degrees, 60 degrees, 60 degrees. So that means that if it's equiangular, it's also equilateral. So that means that AC, this whole thing, is 12. That means that AB is 12. And now, I mean, come on. This is the simplest triangle in the world. Now I'm going to read what they want, because I legit did not read. What's the length of AD?
Oh, bruh, come on.
What's the length of AD? It's half, man. It's half of 12. It's 6. I'm done. All right, finally, some segment addition. Now again, be careful. Figure not drawn to scale. We're told that PQ is equal to RS. This is not even a proof. PQ equal to RS. So these two things are the same. What is the length of PS? Oh man, simple. So what I did was I color coded these so you can kind of follow along and see what's happening here. We want the measure of PS. First, what I'm going to do is I'm going to solve for X. We have PQ is equal to RS. So this is what I'm going to do first, is I'm going to solve for X. And we find that X is equal to the number 3. I'm going to use this value and see what PQ plus QR plus RS is equal to, let's make this one yellow, is equal to PS. PQ was X minus 1, well X is 3, so 3 minus 1, plus QR is just X, so plus 3, plus 3 times X, so 3 times 3, that's 9, minus 7, and that's equal to PS. That's our answer, so this is what we did second. Really simple. Solve for X, plug the value back in. Another really, I can't believe that this was this simple. We do all that segment addition all year in geometry. I mean, bending over backwards, jumping through hoops.
Applying to the circus, riding elephants through the streets, doing segment addition like that.
And then you see this one here. Again, this problem you might be worried. Like you really might be worried. Oh no, I don't remember inscribed triangles, circles. This is not something that comes up a lot. But what I'm going to do is really use an approach that's a common sense approach, and I promise, just stick with me. So here is the radius. Now let me just make this look like the radius. So here's our radius, right? So this radius is PB, it goes around. And notice, this is also the radius, right? It's the center connected to a point on the circle. So PC is the same as PB. This is also the radius. You see how I'm using the radius to figure out some sameness. So what I'm going to do here is I'm actually going to connect this line. I'm going to connect P to A, and I'm going to use the fact that it's the radius and that all these are radiuses to make some assumptions. Watch this. This is a radius, PB is a radius, so it's the same. Also, these are the same. And now, when I consider just this triangle here in purple, it's an isosceles triangle. And what do we know about isosceles triangles? Well, the base angles are congruent. So angle A is 20. And that means that on this side will also be 20. And what can I do here? Well, I can find the measure of this angle here in yellow. And the whole thing has to add up to 180. So I know that this big angle P in yellow will be 180 minus 40. So this is going to be 140. Well, this is 140. That means that this is the same triangle here. In green is literally the same triangle. And so that means that this measure is also 140. And that just leaves me with the measure of x. What happens when you go all the way around the circle? Well, we know that the total way around the circle is 360. So I'm just going to throw equals 360 over here. So I know that angle x is here in blue, plus, I'm going to go clockwise, plus 140. So I'm kind of going around the circle here, going around. So I'm going to go, this is a little circle in here, right? So blue piece plus white piece plus yellow piece is 360. Blue piece plus white piece plus yellow piece is 360. So we have x plus 280 is equal to 360. And then simply subtract 280 from both sides. This looked like a mess, but really just having the idea of what the radius is just completely took it down. So that's what I have for you. As always, if you found this helpful, hit the subscribe button below, hit the thumbs up, and stay tuned for more math.